So what I'm going to talk about is a topic that I've been working on. This is a presentation that I gave once before, but I'm massively changing it right now. So you kind of caught me at this moment where I haven't finished it, but I'm working on some really interesting ideas, and I think you'll find it at least minimally interesting and hopefully more interesting. I've been a huge proponent of platform as a service for many, many years. Interesting note, 6 and whatever years ago, June 2008, when we had our first cloud camp, there were a couple of very interesting people at our first cloud camp in June in San Francisco. And it was an unconference, so people could propose topics. One of the topics that people proposed was, what's a platform as a service? One person who was in that event, at that cloud camp, was a guy named Chris Richardson of a company called chrisrichardson.net. And I think many of you have seen him speak before, or if you haven't, you should. But he's spoken at this group not too far away before. And he went on to, he had just purchased the domain name Cloud Foundry. He hadn't written much code yet. But he ended up writing a process where he could deploy a WAR file and scale it horizontally on Amazon. And that little company he created got acquired by Spring, which was acquired by VMware, which then recreated Cloud Foundry to do multiple languages, and spun that out as Pivotal. We all know what Pivotal is, some of you actually using that product. So that concept, the Cloud Foundry concept, was sort of just getting going when we had our first cloud camp. And so I was a proponent of the platform as a service concept, even before that, really. Another person who was at that same event was a guy named Isaac Roth, and his co-founder, I'm blanking on his name right now. Anyway, so they didn't have a name for their company yet. They came out, they wanted to sponsor the event though, so they came up with a quick name called OSS 1701, which is a super geeky name. Stands for Open Source Software, and then USS Enterprise 1701, right? So, that was a terrible name for a company, but that's what they came up with. And then they eventually changed the name of that company to Makara, which they eventually got acquired by Red Hat and is now OpenShift. So those folks were formulating the ideas for what is now the most popular open source platform as a service platforms on the planet. And I've been participating in that discussion all along. So I've seen this process. I've been involved both as a developer and as a user for many years. And what I want to share with you is some of the things that I see come along around containers and how that's going to impact what we're doing. So first of all, again, here's some information about myself. Yes, we agree that cloud computing is just about everywhere at this point. If you go give this presentation to a bunch of sysadmins at like a Linux conference, they'll disagree. But I think in general, I think we see that it's coming, or it's pretty much here. It's not a surprise, really, considering the fact that Steve Jobs gave a talk about using storage as a service. Didn't call it that, but basically the same thing in 1997, and he'd already been using it for 3 years. So, this isn't a surprise. Basically, at this point, it is unstoppable. For better or worse, call it a rip-roaring train that's blazing, or one that's going to, crash and burn and turn us all into slaves. I don't know, but this definitely is happening, and we basically like it primarily because instead of everyone kind of doing a half-assed job for themselves, you can do a really, really good job for a lot of people, and so you can do the job right, and then lots of people get to benefit from that. At this point, I think we're kind of all on board, and this thing's coming along pretty well. And now all of a sudden we've got this new concept called containers, which of course is not really a new concept, but it is new in that it's now usable and easy to use by mainstream developers and technologists. So containers are pretty much becoming the thing, and it makes sense that they would. And now there's not just Docker containers, but there's all these other container products coming along. I think I just saw that Red Hat came out with an OS focused on containers today. Of course, there's a Rocket container, which is supposed to be a little bit more standards-based or something. Who knows? We'll see how this turns out, but there's more than one container out there now. Canonical has one called LXD. I think Drawbridge, I don't even know much about it, but I saw that Microsoft was working on it. So we'll see what goes on there. But At this point, everyone's, hooray, we love containers, rah, 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 we're all on board. All right. But guess what? Containers aren't perfect. Containers give you the ability to scale up lots of them faster than ever before. And guess what? That can go haywire faster than ever before. So as you guys know, that containers are kind of like a virtualization within your OS, and you can spin up multiple of them really quickly. You can lose your handle on those things, and then it's just running. What are you going to do? So you have to figure out how to find it and shut it down gracefully, all that kind of stuff. So there's a lot of stuff that goes into making them work effectively. On top of that, there's a lot of manual labor that goes into figuring out how to make these things work. At least right now there is. So there's a lot of details you have to deal with, networking, security, all that kind of stuff has to be figured out. And sometimes things go a little haywire. You might get some containers, you might lose a container, or they might stall or stop responding or something, and you don't know what's going on. So anyway, it's not all a bowl full of cherries. So furthermore, not only do you have to manage all these containers, but you also have to worry about the OS. Now, this is better than virtualization, where within one physical box you might have many different OSs. Now, at least within one system, you might just have one OS. Okay, that's a little better. But if your application is running on many servers, you're still going to have all these OSs running on those servers. So you still have to deal with that. Which means that there might be patches and upgrades you have to do because you don't want viruses and worms in your system. And there's lots of restarting of services that might stop, and there's, of course, you need to back up and restore all of your stuff, and you have command line tools that you got to use and learn. So, like I said, it's still a lot of work. Now, I'm a developer by trade, but I've worked with lots of different types of developers. And not just developers, there's other types of technologists out there, sysadmins, IT folks, all these kind of folks out there working in the cloud computing space. And so, this is a snapshot taken of perception of different types of developers, but you can apply this really beyond just developers. And these are all people of different skill levels that use cloud computing, who use infrastructure as a service. And some of these folks have a formal training, or maybe they've learned the hard way, but they've got the skills that they need in order to use infrastructure as a service very easily. Others, not so much. I just came back from Bangladesh, where everybody there is a massive WordPress enthusiast, and they love PHP. It's probably not the place that you go if you have a strong skill set in, actually it would be a great place to go right now if you have a strong skill set in cloud computing, because there's a lot of people there who want your services. So anyway, there's lots of different types out there. Now, with cloud computing and infrastructure as a service, there's a lot to learn. You not only have to program and write your code for your application, you need to manage the infrastructure. And those are two pretty different skill sets. So you've heard about DevOps, and that's basically what's going on there. You've got your application developers working with your operational team, and they're figuring out how you can write your code and deploy it in a sort of seamless, continuous integration, continuous delivery, continuous development, deployment, all these different continuous words. And there's a lot of skill sets that, like peanut butter and chocolate, go really well together, but aren't necessarily easy to blend. So you've got looking over each other's shoulders, trying to remember how things went. Hey, how did I do this? How did you do this? So that's typically what happens. You need at least two people to get something deployed, written and deployed, which is okay for some. There are these superhero developer sysadmin unicorns out there, and they can do all this stuff, but there's just not that many of them, quite frankly. There's a lot to learn and keep up with. There's a lot of sharp objects. I mean, for me, as I'm mostly a developer, I work hard to get my sysadmin skills going. I can do it a little bit, but every once in a while, things don't go well, and I've dropped something heavy on my foot. So a lot of things you can bump into and hurt yourself. So my point really is that infrastructure as a service, even with containers, is still fairly hard. There's still a lot that's going on that you have to know. And in my experience, that's just long enough, just goes back just far enough back to the Windows days, and even the pre-Windows days just a little bit. If you remember, what made the PC era initially successful was not a rich GUI with lots of functionality. It was the Apple II. It was DOS. They proved the market. And then eventually we ended up with the Macintosh OS and Windows. And in my opinion, infrastructure as a service is effectively the same thing. It's a rudimentary, bare minimum, viable product that shows us that cloud computing is a good idea, but it's not what we're going to end up with. What we're going to end up with is something more along the lines of PaaS, where things are provided in a better way for you, and you can build your applications more rapidly, and your users are getting more value and more consistency. So it's only natural, I think, that we end up with this. You could say that, I'll let you guys think about this later, but you could say that Amazon EC2 is the Apple II of the cloud. You could say that OpenStack, or yeah, let's just say OpenStack is the DOS of the cloud. You could say that. Okay, infrastructure as a service. I know, people laugh at that, but the metaphor holds up pretty well. You could say that either maybe Salesforce, Force.com, or Heroku perhaps is like the Apple Macintosh of the cloud, right? A proprietary system running on a cloud that, that they chose, not you. Or you could say Cloud Foundry, or another container-based PaaS, is effectively going to be the Windows, or perhaps the Linux, if you will, of the cloud. And I really do believe that. In fact, the metaphor holds up even better when you consider the fact that when Windows first came out, okay, trick question for you. When Windows first came out, what operating system did it run on? DOS, right? When Cloud Foundry first came out, what cloud operating system does it run on? A couple of them, right? Not DOS. That's funny though. No, it runs on OpenStack or Amazon EC2. Basically, the DOSes of the cloud is what it runs on. So the metaphor does continue. And Cloud Foundry is built more for the enterprise, but there's others that are being built more for startups. So, and they have a similar metaphor. Anyway, that's where I wanted to, that's part one of my talk. The second part is that if you take a look at not only the technologies, but you start looking at the developers, the users, the ones who are using the cloud, building applications. I'm starting to notice a trend where these newbies are coming in and they've never developed anything but cloud applications. Ever. In fact, these folks have never even built a web page. They're now going straight to mobile app development. Okay, this is a group of people who never, ever, ever saw a phone line with a cord. They don't know what a rotary phone. They have no idea what that means. Okay, they don't use email very much. All right, of course they use it a little bit, but mostly not so much. Using texting and whatever. So Snapchat and WhatsApp, that kind of stuff. All right, that's what they're doing. And so there's a whole new generation of developers out there. And they're pretty young, and they have this attitude that's like, I want instant gratification. I don't really care about being locked in. By the time I'm locked in, I've already won, so who cares? Okay, that's what's going on. So they're building apps on platform as a service specifically built for mobile, which is basically an API that manages all your users. So that is basically lock-in as a service, and they don't care, okay, because they're going fast. So that's what we have to compete with, or at least work with, if we want to be successful and know that they're out there, and we better move just as fast. So they want something really easy. So for them, platform as a service or mobile backend as a service is basically for them the easy button, which for you and me, we know that doesn't always work out that well. Doesn't always work out the way you expect, but you know what, who cares? Crash and burn, move on, do your next startup, right? So anyway, I think platform as a service is an excellent kind of middle ground. You get all those benefits. If you use open platform as a service, you don't get so much locked in. You still can migrate, even though you're locked into perhaps a framework, but you can at least run it in different environments, so you're not locked in quite as much. And with a container-based platform as a service, you're still going to have containers, but you know, you'll have fewer instances of an OS because there's only one OS per machine. Whoever's managing the platform as a service gets to deal with all the patches and upgrades. You don't have to. You don't have to deal with viruses and worms. They can deal with all that. There are services that are provided by the PaaS that you don't have to set up. Hopefully they've got a database for you already going, so you don't have to go and install and manage that. And storage as well, all set up for you. If the platform is kind of robust, they may have redundancy and backup all built in, so you don't have to deal with that as well. They'll do things that, like if you've ever tried to deploy an application within a company, you know how difficult it is to get an IP address, how to get a subdomain, how to get other services for your application. Well, if a corporation has implemented that PaaS, then they have figured out the rules that will give you those, under which conditions they will give you those services, so you don't have to wait. Okay? Maybe they give you everything, but you can only deploy into development, right? Or development space. Okay, fine. At least you can get something going. So this is coming along. Now, how do we deal with this in the world of platform as a service, but with containers? Because this is, in a way, somewhat of an orthogonal view on things. Because with platform as a service, typically what we've been doing is deploying our code on top of instances that are running. At least that's how it feels as your developer user experience. But with containers, especially with Docker containers, that's really not how it works. What happens is you write your code, you build your environment, and you create a Docker image or a container image, and then you push that to where you want it to be tested, and then when it works, you push that to production. So the image is moving around. That's a little bit different. So they've got this concept of build your image, push it up into a repo, then pull it down to be tested, run it to be tested, and then if it works, go push that into production, right? So this image is moving around. What's nice about that is if you know it runs in one place, most likely it's going to run in the other, right? Nothing changed as far as the bits go. If you've pushed enough code in your life, you know that pushing code repeatedly does not result in the same thing. There's this thing called physics. If networks are bogged down, or if physical equipment isn't working quite right, sometimes you don't get all the bits in the places that you thought they'd go, and things don't work as well as you thought. So having an image actually is a little bit more likely to result in a consistent state. Okay, so within a Docker image, basically you're putting all of this. You're putting your they have this thing called the Unity file system that gives you these layers. You can put all your code in, build up these layers, push this thing around. It's got your code. It's got all the supporting code that you need. It's got the container. And that's all running on Linux, at least today. Now, here's a challenge for you. If the developer builds all that, what about the folks who got to support it when it goes into deployment? They might not be the same person as the developer. Might be someone from IT, perhaps, or whatever. So who decides what that stack looks like? Is it really a good idea for, if you're in an enterprise, for a developer to just put whatever they want in the container and just push it? Probably not. Now, there are ways to protect around that. There are solutions for this, but my point simply is that it's not just as easy as it sounds. Now, one thing that I've picked up on with Cloud Foundry is that it relies heavily on this concept called build packs. I really like this idea. And you can use it with containers too. So a build pack is basically all the stuff that your application code needs to run, except of course the OS. So you put like the JVM or the PHP runtime or all the different bits that you need into this build pack, and then when you deploy your code on 1,000 servers or one, doesn't matter, it's going to put that same build pack on all of them, and your same code is going to go on all of them, and now you got this nice stack. This concept is catching on, and so I'm going to jump to my punchline here, which is basically take a look at using containers as a developer and use a build pack. You've got some consistency no matter where you decide to push. All right, that's the punchline of my talk. But let me just wrap it up here. If you're wondering what build packs really are, well, basically it's a fundamental concept that was created by Heroku. They use it, they open sourced it, and now it's catching on in other places like Cloud Foundry and this startup called Deis. And you know, like I said, it has inside of it the runtime for your code, a list of dependencies that need to be downloaded or installed, other configuration files and variables. It specifies different runtime options, like what code to run or what line to run when you want to actually deploy your application. So there's a lot that goes in there. This concept, I think, works really well within a DevOps environment. And as I said before, you know, it can be, you can put the build pack in a container, save that, and that's what gets shipped around, right? And everyone agrees that that's what your technology stack looks like inside of that image. And then the only thing that's changing every time is the application developer's code. You know, the developer's code, of course that's going to be changing, right? So you push that on top, but everyone at least relies and agrees upon that basic stack. The QA, the production, everybody, right? And then what does that look like? You still have your container running on Linux with the build pack in it, and then you put your application code on top of that, nice and clean. Now, I will say that if you are kind of all in on the Docker world, that makes sense too in a different way. If you've taken a look at the microservices world, what's going on there, it's a little bit different. You don't really have this concept of developers and IT. You don't even really have DevOps. You basically just have like an engineer or a team building a service and deploying it and maintaining it all themselves. They're the ones wearing the pagers. They're doing everything. All right? And now in that world, they might be able to decide their entire stack. And so building an image with your application code in it and pushing it all around might make perfectly good sense because you control everything. So Docker containers or containers in general in that microservices world actually, I think, makes a heck of a lot of sense. So in that case, maybe you do put everything in your container, but I still think you use build packs. And then, okay, then you get to go back and you can live in this, you know, Docker workflow. But I think right now this is an edge case in at least the world of IT. Although, like microservices and startups, this might work fine for. You got a small enough group they can, you know, adopt this new concept. But as for the rest of us, I think that we basically want something like this. And the best way to achieve that today is with something that uses the build packs and put those in the containers, and you separate your code from that, and you deploy and have it managed by a PaaS. And today, what I recommend is Cloud Foundry. That's what I like. But there's others coming along that can do the same kind of thing, and there's other ways of doing it. So I'm going to wrap up my my talk right now, and I'd like to open up I left enough time just to have a few questions. So I'd love to hear your questions. And again, my name is Dave Nielsen. I'm a cloud computing enthusiast, and I'm giving lots of these talks, and I'm organizing unconferences and hackathons to continue this concept. So whatever we talk about, I might use in my future presentation, so be aware. Thank you very much.
Question.
Yes?
So, Pivotal and IBM are taking Cloud Foundry forward. Can you briefly say what is the value add which one is providing?
Yeah. Actually, it's really simple. So the question is like, well, if we've got this Cloud Foundry thing, then what is Pivotal and IBM offering, right? So first of all, IBM has put a lot of effort into getting Cloud Foundry to run on Bluemix.net. Okay, seriously, like a lot of effort, and it's showing. It looks good. It works really well. They're also going to offer it private cloud as well, or managed. But my point is that they really went all in, and they've got Watson running as a service through APIs inside of Bluemix, so you can actually go write code that talks to Watson and does who knows what's going on there. So pretty interesting things are going on in Bluemix, right? If you take a look at, I just did a search on Google Trends for the word Bluemix versus Cloud Foundry. Bluemix is actually beating out Cloud Foundry now. Okay, so IBM's really, really going all in on this thing. Their conference they had like last week, they basically used to have like these 5 major big conferences, one for like their database, one for WebSphere, well, they put them all into one, and they didn't call it the Bluemix conference, but you might as well. It's just like this massive conference all about things that happen to be related to Bluemix. So yeah, Interconnect, what's it called? Interconnect, okay. So Pivotal, on the other hand, is really all in on the private cloud. They put a massive amount of effort into getting this suite of technologies to all work around Cloud Foundry that can run on-prem. So that's like they're massively focused on that, and they're doing quite an excellent job. And they also have put a lot of effort into running Pivotal Web Services, which basically competes against Bluemix. But I think they kind of started off in these opposite directions. So Bluemix started off with the public Bluemix.net, and Pivotal's really started physically more on the private cloud, and I'm sure they're going to compete in all these spaces, but that's where I see them starting from. And when you ask the question, like, what's the value add? Well, what's the value add that Red Hat offers to Linux, or Canonical, right, with Ubuntu? Like, what's the value add? Well, the value add is Cloud Foundry by itself works, but you're going to put a lot of effort into making that work, right? And it primarily focuses on the compute part of it. It doesn't really do the rest of the things that you need out of the box, right? So like databases don't really come with it. You're going to provide your own database, all right? You're probably going to have some storage system that you set up that's more than what Cloud Foundry comes out. So what they're really doing is providing the additional packaging and services that really make it a complete solution. And if you go with an IBM or Pivotal or any of the other companies, HP, what you're really doing is you're betting that they're going to continue adding value and that you're going to invest in that stack. And as your needs grow around their Cloud Foundry distribution, they're going to continue to add more features and you'll benefit from that. So that's where I see the value add that these companies offer. And then you've got companies like GE, which I should learn more about, but I kind of imagine that you're kind of building a vertical stack around Cloud Foundry. It's, around, what do they call it? The
Predix platform.
Predix platform, but it's like the industry internet or
Industrial
Internet.
right, industrial internet. There you go. Which is like the Internet of Things for a GE scale. So like instead of like a thing being like a phone or a sensor, to GE a thing is like a manufacturing plant.
The commercial side versus the
consumer side, right?
Yes.
Yeah, commercial size versus consumer size, right? So yeah, it's very fascinating, and I think that we're going to see Cloud Foundry being applied to lots of different vertical industries, and so it's a very great and interesting opportunity right now to get involved with Cloud Foundry. All right, so long answer to your short question. Sorry about that. Anybody else have any questions or ideas? Yes, right there.
So, you talked a lot about build packs, and I'm pretty sure I can see where it goes, but, obviously, if you're going to start talking about, hey, all of our developers build on a certain build pack, where is the contract or the audit trail, or however you want to phrase that, to, where are the tools to help me enforce that?
Right, well, good question. So different platforms will handle that different ways. Some don't handle that at all. But like, for example, within Cloud Foundry, you can specify only use build packs that have been set up in the Cloud Foundry repo, for example. So then you have to use that. It won't deploy your app if you don't. Now, built into the concept of Cloud Foundry is you can specify in a manifest file, go grab the build pack from who knows where. Like you can specify the URL to it up on GitHub or wherever. So you can do that, but again, you can lock that down, and that would happen within the Cloud Foundry configuration. Yeah, like I said, like different platforms might enforce that different ways, and I'm not quite sure how else that might work out.
Yeah, it just, if that's going to be one of the features, then that, the enforcement mechanism is necessary.
Yeah, and it might be rudimentary today, like yes or no, right?
Yeah.
I mean, maybe that's all it is today. Maybe there should be more functionality around that, but hey, it's open source. We can put that in there and then see if they accept it, right? We'll see. We'll see what happens. Okay, any other questions? Yes?
Question. So you mentioned there's some security concerns about using Docker containers, but even though it's not like full hardware virtualization, OS level separation, but still have a fairly good, application level resource isolation. So,
Yeah.
so why you think that it's a security concern?
Well, okay, so I am by no means an expert in security, so let's just get that out right away. But what I believe in general, I think you're right. In general, I think it's fairly secure. However, I was just at a conference where on the panel, on the Docker or container panel, were folks from Google who are running containers in a massive scale, Docker, CoreOS, and one other big name who I'm blanking out on right now. But anyway, they basically all agreed that if they were running their application in a container on a server that had applications from other companies on it, they would not feel secure. So there are ways in which you can get around security inside a container-only environment that doesn't have the virtual machines. Okay, so the virtual machine today, apparently, according to these, I'm just repeating what they said, does a really good job of isolating that all the way around, wrapping it nice and secure. Containerization only does not, especially with Docker, because Docker apparently makes it possible to, again, I don't know how they do it, but it's potentially possible to get down and change things in kernel land where you wouldn't even know that something's changed and they're like reading everything you write. So it's possible, I'm not saying it's likely, I'm just saying it's possible, and it's possible enough that everyone on the panel agreed that would not be a good idea. So maybe it'll get fixed at some point, but that's just how it is right now.
Docker is virus.
Huh?
Creating the Docker is virus.
The Docker virus?
Mhm.
Is that what we're going to start promoting? Is that what we're going to tweet that right now? Like, Docker is a virus. Docker is a virus. Please retweet.
Docker as a
Joe.
virus.
What's that?
Docker as a virus.
Docker as a virus. There you go. DAAV. Hey, that's pretty close to Dave. I don't like that. Okay.
It
Yeah.
might be a stupid question. Is Docker's production ready? I mean, is it gonna be, because still, like when GE decided to go with Cloud Foundry,
Yeah.
they still don't go the Docker's way, they're going Cloud Foundry.
Honestly, I don't think it is for enterprises,
Okay.
but I do think it might be for startups. So if you're building in one application, it's going to run in the cloud, and all you care about is running that one application, and you're not going to share your environment with someone else, I'd give it a shot. I don't think that's going to be too dangerous. But I mean, an enterprise doesn't work that way. I mean, there's not lots of applications. There's security unknowns that just aren't worth the risk at this point. Set up a lab, try it out, but I mean, I just genuinely don't think it's quite that ready yet for an enterprise with lots going on.
But you seem to believe big in containers, right?
Well,
Especially.
I believe big in Docker. I just think that it's got a little ways to go. I believe bigger in the concept of containers, and I even believe even more in the concept of PaaS. So, for me, it's the PaaS concept, and containers are just an excellent way of doing that. But PaaS is what matters, right? Windows is, maybe we shouldn't use Windows as the example, but Windows was quite successful. It still makes more money than all of the other Linux companies combined, right? So I mean, if you're interested in revenue, you're interested in generating value for your customers, then PaaS is going to do that for you. So yeah, I definitely believe that. And then all of the changes that might go on underneath over the years to make that better, I think containers are going to be one of the big improvements. Yeah.
Do you foresee a future where containers will absorb all the things like Docker and CoreOS are doing, so you don't need big wrappers?
Well, okay, so remember how I said when Windows first came out, what operating system did it run on? It ran on DOS, right? So Windows came out, it ran on DOS. Now, does it run on DOS today? No, it subsumed DOS. It emulates DOS. It became the entire thing. I think PaaS will do that someday. I think the idea of, it might be 10 or 20 years from now, I don't know, but I think the idea of a PaaS eliminating all the complexity at the infrastructure as a service is the same thing as infrastructure as a service eliminating all the complexity of individual operating systems and servers running in virtual machines, which is the same as virtualization, making it simple to run the OS as bare metal. So we're always kind of evolving the stack and creating a greater platform that kind of hides complexity, and I think that will just continue. So yeah, I do, and it might be completely reinvented again 25 years from now when everyone's like, monolithic is bad. I mean, who knows? But in the short term, I think this is a trend that we can count on. Yeah. So just out of curiosity, just so I can kind of wrap this up and feel like I had some impact or interest level. I'm just curious, like, is anybody here actually implementing or trying to use some sort of platform as a service or some containerization solution? Either one. Hands up. Okay, 1, 2, 3, 4. Okay, good. That's like over 10. That's great. Does anybody want to share anything about what they're doing that maybe I didn't touch on or is different, or tell me I'm full of shit? I mean, whatever. It's just, anybody have any ideas that they want to bounce off the group?
What about problems that people are facing with deploying containers? Like, as you virtualize all these different services and put them into containers, your footprint for your application or whatever you're building drastically increases.
Yeah, if you listen to the poster child for a lot of this stuff, it's Netflix is they've kind of ended up building like their own PaaS kind of. And they did it with images too, by the way. They build images and deploy those. And if you ever see a diagram of all of their microservices that basically run that one monster application, you can't even track all of the lines.
Hystrix.
What's that?
Hystrix is
Yeah.
very big.
It's just amazing to look at all the different services that talk to each other and try to track that. So imagine a world where like each one of these little components is talking to many components. Well, each one of them needs their own API key, basically. Serious, like, because you don't want to reuse the same keys. Those get out, and now all of a sudden somebody gets into your network, they can touch everything, right? So you kind of have to have like unique API keys for everything. I mean, that just sounds really complex. And some companies, like banks and stuff, they're going to want not only API keys, but digital certificates.
Yeah.
Okay. Cloud Foundry lets you use the concept of a digital certificate for like multiple subdomains. Some companies don't allow that. So now every time they create a new app, they got to go generate a whole new digital certificate. So in my opinion, like all this flexibility is creating massive amounts of management issues. And so that's why all these vendors like all that stuff, because they're going to go create some management software for you that you're going to pay for because you have to figure out how to manage all this stuff. So that's what I see as the challenges. Security, managing complexity, because that's what we're building is like a massive amount of complexity based on one platform, which makes you build even more complexity faster. So
What about the performance side of stuff? As you, like you said, as you add the additional,
I don't
layer
think
of virtualization.
performance is the problem, in my opinion. It might be on the high end, but then maybe you have, maybe you're doing something so important that you should just have a dedicated resource to that. That's fine. A dedicated custom stack. If you're building a stock market trading app, you need like sub-millisecond trading there. So is that even possible? I think it is. But anyway, yeah, you need something super fast. So that's probably not going to be Cloud Foundry or any of these things. It's going to be something highly specialized. But what I like to promote is the concept of not only can you run massively scalable apps on these passes, more importantly for companies, especially like GE, et cetera, is you can run the long tail of apps on these passes. Because guess where your competition is coming from? It's probably not the next big guy, although that's what you face day to day. It's some little startup that's building some app that's way down the long tail that you don't even think about. So as they're coming up the tail and then competing with you, like you have no way to fend them off because you're stuck only building these big, massive apps. if you can build smaller long tail apps and explore and innovate a little bit more, maybe you can kind of meet them further down the tail and fend them off a little bit sooner. Or run into them sooner, identify who they are sooner, right? So anyway, that's just the way I look at it. It's not only a scaling platform, it's a long tail platform. All right, I'm over my time now by at least 3 minutes. So if you have any more questions, I'm happy to talk afterwards, but I'm going to end my part of the talk right now. And now let's go ahead and introduce our next speaker. Come on up, Victoria. I'm going to get you. Yeah,